Hello, my name is Vadim Voitenko. I'm a founder and maintainer of Green and today we are going to speak about the topic that called running open source database on AWS is easy, but using real data for development is not. So just short introduction to this topic is that plenty of people telling that it is easy to run the database, but when you're trying to test your services in a reality, like kind of implementing your um, real infrastructure with the kind of production-like data, it is getting more and more complicated task to achieve. And before we begin, allow me to introduce myself. So, as I told you, my name is Vadim Voitenko. I'm a backend engineer and the founder and the main maintainer of a Green Mask. I used to work in different domains like educational technologies, healthcare, banking systems, and infrastructure. I used to be as a database engineer for a long period of my life. I'm active open source contributor into PostgreSQL related software and open source itself. In my spare time, I'm passionate about motorsport and cycling. Our presentation is divided into parts: the research and how the your testing environment might be implemented. So let's start from the research. But before we begin, let's recall the common typical development flow that we have. Imagine we have a common product task that we have to complete. We need to implement a new feature. So we're developing a code, building it, testing it in our local environment, let's say running unit tests and so on. So we're just validating in our local machine. And then maybe we're deploying, right? But I don't think it is enough. That's why plenty of companies trying to implement their own integration or staging environment that has real dependencies. It is shared across multiple teams, and there are plenty of services and the responsibilities of each team. So let's say we have a team A, team B, and all of them has their own services and their own databases, and there is a kind of common queue that is used in order to interact between these services. And that's good, yeah, right? Because we can test this in this shared environment with the real dependencies and maybe find kind of bugs before we deploy it into production. But it sounds fragile because we have shared environment that is accessible across different teams. It is hard to control because if one day one team decide to deploy their own release, it will be deployed in this shared environment. It might break down the environment, kind of services, and it won't be accessible, especially if it is centralized service, kind of service that provides kind of user information. Yep. So it's easy to break. So and the another problem is that if we are deploying kind of a new revision of the service, it means that it might change the data itself within the stateful services. For example, database. Imagine we have deployed a new service revision in this shared environment, and it is just decided to delete the user table. So meaning that kind of services that cannot operate correctly right now, and plenty of teams that currently using this environment cannot check their integrations, and we have kind of a small incident, right? So, and how we are going to fix it, that remains unknown. And plenty of companies don't have clear procedure how to implement it, and they don't have even kind of SLAs for it. And there are plenty of questions that might be found after this speech. There are many dependencies, different services, queues, databases, APIs, and so on. It is hard to maintain during the software lifecycle because the because different teams can deploy everything just in a moment, and one service may fail, and so how to fix it? There is no isolation at all because it is a shared environment. And many other questions that might be caused here. If we are going to implement a production-like environment, how are we going to deliver the production-like data? Maybe we need to get the data from the production and anonymize it. How? Maybe it is not so easy, and you might meet a data leakage in your testing environment. Maybe you need to generate the synthetic data, but how? Again, and the consistency, how you can get the dump consistently from the different services and deliver it consistently and deploy it consistently. And the downtime, if you're going to refresh your shared environment, how long it takes. So many questions. And the dump and the data problem is the central problem in my point of view, because plenty of bugs in our software comes not from the bad testings, they rather comes from the lack of the real data or the real conditions. And the ordinary vibe in our companies is like we have a production environment where only a few people has an access to the services and databases itself. And we have a testing environment. In testing environment, all developers has an access. So we are developing here, we are validating our ideas. So sounds good. In production, we are getting money, it is isolated, only a few people has an access. If you want to deploy a new revision, you're going through the CI/CD system, and now you have a new revision of your service in the production. But the problem is that these two environments, in most cases, cannot be synchronized, because you cannot just simply move the data from the production to the testing environment, especially if it is untrusted testing environment, right? So that's going to be a big problem. That's why in this particular, in the centralized, in the central part of this image should be a test data management software that could help us to deliver a proper production-like data to our staging environment. And to test reality, you need two things. Reality itself, right? Because we need a production-like environment that has real dependencies, real services, that looks like a production. You can deploy the stateful services, kind of databases and so on, with realistic data that is currently locating in your test data management system. And this data is consistent across different services. Since we have many services, their data should be consistent because they're using different databases. And the control would be nice to have an isolation, because if I deploying kind of services that deleting kind of table, it will just delete a table only within this ephemeral database that is currently used only for this environment, for this testing. Reproducibility, it is also achievable because we have a production-like environment and realistic data, and fast provisioning and rollback. So I don't want to wait ages while my environment is redeploying. And that's why companies trying to achieve ephemeral environment using by implementing their own internal developer platform. And I can say that there is a particular way to implement it. There are plenty of technologies, and they are resolving the specific requirements for this internal developer platform. For example, on the right side, you can see the logos. Neon you can use for PostgreSQL and instant branching, as well as Xata, but Xata also provides the test data management capabilities as well. OpenEverest is the good idea to implement ephemeral environment since it supports plenty of databases. You can easily spin up it and so on. The green mask supports test data management capabilities, so you can deploy your database dump on a, well, let's say, on a database that was currently started in OpenAWS, for example. And AWS might be used for kind of execution layer where you're running your Kubernetes pods or just virtual machines. So the requirements, in my point of view, are the following. We should have an isolation database as a service with instant branching, meaning that we could place a save point and roll back to the specific period of time just in a second. The garbage collection, because since this environment is the ephemeral, we need to wipe everything once we've completed our task or feature. The test data management should deliver the data to your newly created databases. But since test data management might use the data of the real production database, for example, yes, you will anonymize it or sanitize it by removing some table, but still you have to have a control how this data is moving within your organization. And data security posture management should help us because it resolves kind of capabilities such as data classification, and kind of data lineage, right? So that's how we can understand what kind of data is storing within this database and how it is moved to the less strict environment. And what we expect today. The AI is employed always, almost everywhere. So we are using AI agent. Managers and C-levels understand it clearly that developers can perform better because most of things of routine tasks are automated by AI agent. So we expect rapid iteration. Development is just getting faster. And to understand how it works right now, let's have a look at the common AI agent development cycle, right? So imagine I have a, let's say, kind of cloud code and a feature that was assigned to me in a company in order to add it to the new service or to the existing service. So I'm writing a prompt to the agent starting developing it, and creating a bunch of codes, deploy it, and validate the results. For example, that should it go further or should it roll back? And here is the main problem currently. If the agent will decide that he has to roll back everything, meaning that it has redeploy your infrastructure. In this particular case, if you're running everything in the local Docker Compose, you have to recreate your whole environment. It is nice when you don't have a big databases within this Docker Compose, but it is not good deal when it is quite huge. And it would be nice to have a feature that help us to request a save point for these stateful services such as databases and roll back if agent considers this as required, right? So in this particular case, we're just redeploying the stateful services and rolling back as fast as possible the, no, vice versa. We're redeploying our stateless services and rolling back as fast as possible using this kind of branching system or safe rollback, safe, features. Within our stateful services. And sounds like we are living in a broken feedback loop. We have more changes, more iterations by the performed by the agent or the user itself, by the developer. Managers expect the faster expectations because they clearly understand that plenty of routines are automated. The AI agents anyway have to wait each iterations, meaning that this should be somehow optimized. We need a reliable environment that should be ephemeral in my point of view. Since the iterations is faster, looks like we're having more bugs, so lower quality. and even more pressure from both sides, from AI, from managers, from the businesses, and so on. And the main bottleneck, in my point of view, is the stateful systems, slow iterations, because we can't simply roll back to the specific save point as fast as possible. And it is nice to see that current infrastructure is evolving. And there is an example. Signadot is kind of a startup that is providing an ephemeral environment approach. It's kind of ephemeral providers, let's say. It works in the following way. It allows you to spin up the kind of sandbox, for example, in your Docker, or just run the service that's built locally in your machine, and use the services if they have a dependency, yeah, right? So we don't have one services. For example, in this picture, we have service A and B, and they're interacting between themselves. And you can see that service A and B are deploying in the K8s cluster. And so they are in a shared environment. And when we're creating a new feature for service B, we could create a local instance of the service B that currently built. And using this Signadot software services, we can access to the service A that is currently deployed in a shared Kubernetes cluster. So it means that we don't have to create locally all the dependencies of the services. So if we are developing only one services, it is a good idea to have an instance of the service that you're currently deploying on your local machine. And instead of mocking on deploying all the other services, you're just accessing to the services in a shared environment. So, and how this might be achieved for now. In this section, I'm going to show you different schemas for shared environment, local environment, ephemeral environment, and future-ready environment, but I'm not going to rely on specific software. But anyway, since I'm a maintainer and developer of GreenMask, I have to recall and make an example of the test data management tool. It is GreenMask itself. It is the test data management tool that is created for database anonymization, synthetic dump, synthetic data generation, and logical dump. Formerly, it was implemented only for PostgreSQL, and currently it supports MySQL. It is in progress for now. It has a rich functionality such as validate. You can validate your config against the real data. See the warnings if there are any, for example, constraint violation and so on. You can anonymize the data or create your own transformers that depends on your business domain, right? You can subset your database consistently, meaning that you can scale down the huge database up to small size of database using kind of where conditions. And it has different storage. So if you're interested in, have a look. You can use the QR code and see the GreenMask repository. Well, shared environment is kind of obvious case. I think plenty of companies and has this approach already implemented. We have a services, we have a databases, and we need to periodically deliver the freshest dump of each databases within this shared environment. So to achieve this, we can use GreenMask test data management or any other test data management tool that gets the dump from the kind of shared S3 storage in your company and deploys it, let's say, on demand or daily, or what kind of schedule you have. It is quite simple, and we implemented an idea how you can do this in your company using the GreenMask and OpenEverest This blog post was written by me and Sergey, the founder of Salonika. So have a look at on left side is a QR code. The local environment is also the good one. For example, you can deploy everything in a Docker Compose. So you have a services, databases, and so on, but still there might be a question how to deliver a freshest dump into your database. So just an idea, you can create a new service that initialize the database. So is the dump received from the Green Mask or any other data management. And after that, you have all the services deployed within your Docker, and you can test smoothly. On the left side, I prepared for you an example how the Green Mask might be employed in order to achieve these test management capabilities in a local environment. And IDP is internal developer platform, and how using your IDP you can achieve a ephemeral environment. The idea is the following: you have plenty of users. All of those users are implementing their own features, and for each feature we have an independent environment where they can test everything. Everything might be broken, so it's not so restricted. And if required, we can just clean up this environment just to remove it and so on. The same thing, we need somehow to deliver the test data using the test data management tool such as Green Mask or any other. And in my point of view, there is going to be a future-ready environment that unites all of those types of environments, ephemeral, local environment, and shared environment itself. We can, let's say, for example, a developer might have its laptop. It has local services that has an access to the other dependencies that are currently running in a Kubernetes, where they are, let's say, shared, accessible by any other users. So we are testing only our services and integrations from the local machine to the Kubernetes dependencies. We have a database as a service with branching that help us to roll back as fast as possible and put a save point if required, and make everything consistently. We have an agentic API that help us to spin up a new environment, operate with the branches, and get the test data management data and so on. And yeah, test data management system that help us to create test dumps for our stateful services that might be taken later either for creating a local instance on your on your developer laptop, right? Or within the Kubernetes environment when you have a ephemeral isolated environment, let's say in one namespace and another one in another. So that's it. And user services that are running in Kubernetes. So in my point of view, this will help us to operate faster with AI agents and just simply developer faster if we are even writing code manually. So that's why I think ephemeral environments are the goal. And this is the direction that we are currently building together with the Salonika, OpenEverest, and the Green Mask. OpenEverest already might be used as a system that provides you internal developer platform where you can implement ephemeral environment. The Green Mask can be used as a tool that help us to deliver production-like data, and we aim that it should be safe and isolated enough in order to test your features, like within your PR or within your feature that you're currently implementing. Yeah, and the another point is that it should be provisioned as fast as possible and rolled back as fast as possible. So that's why the Green Mask has the following plans. Currently, Green Mask is just a generic test data management tool that is support PostgreSQL, and in the nearest time will be published a new version that supports PostgreSQL and MySQL. Meaning that the Green Mask should support any other database management systems such as Oracle or Microsoft SQL Server and so on. So the idea is the following: that we have the Green Mask core, and you can easily implement your own implementation of your database management system, and the Green Mask should be as reliable as vendor utilities are. Yeah, and on the right side you can see the process of the MySQL implementation. You can see this in the issue. The next step is the Grandmaster Test Data Management Platform that provides all test data management capabilities such as data classification, auto configuration, database anonymization, delivery of this database dump to the specific database that currently has just started, and so on. So it's just gonna be an API first platform that help us to resolve our daily basis tasks. And we're aiming to implement OpenEverest plugin that help us to spin up different databases with different engines such as MySQL, Postgres, and so on, whatever, within the OpenEverest. And it should be one of the main way how you can provision your database within OpenEverest. Well, that's it. Thank you so much. Thank you for having me, and I would love to hear any questions from you. Okay,